Intelligent Students, Mr. Lawrence here, and this is your next flipped lesson. We are talking about parallel and perpendicular systems, and there's going to be some other vocabulary I'm going to throw out at you, and we'll talk about it in a minute. Now, I don't know if you realize this, but when we're solving a system of equations, we have a couple of possibilities. We talked a little bit about this. Oops, wrong button, sorry. Ooh, I saw some cookies there, making me hungry. All right. Oh, I don't know why it does that. Let me get rid of that line. Oh, no, another line. What am I going to do? I'm going to delete them. Bonk, they're gone. Okay, let me lock this in place. Thank you. So that way it can't move on me. And let's say I have a set of lines that are like this. Okay. Now that set of lines, that system has a solution, right? It has a unique solution, the exact coordinates of the place where the two lines cross. Okay, I guess if I kind of guesstimate, let's see, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and maybe a quarter. So it's going to be 6, 5 and a quarter. That's the system. When a system has a solution, we call it consistent. It's consistent. Okay, that's a consistent system. Now, furthermore, if it has only one solution, we call it independent. And if you think about it, independent means one or by itself. When we declared independence from England way back in 1776, we were saying we want to stand alone. We want to be by ourselves. We want to be alone. Consistent, independent means there's exactly one solution. Now, another possibility would be we could have two lines that do this. In which case they're actually parallel, right? So let me see here. Let me put some arrowheads on them. And in this case, there's no solution to the system, right? There's no solution. And when there's no solution, we call that an inconsistent system. Now, you may want to make some flashcards of these to keep these terms straight. So when there's one solution, that is a consistent, deep, independent system. When there's no solution, it's an inconsistent system. And there's that possibility that Zach Ingram mentioned, and that's when we have the same line graphed twice, right? Right, where it's actually the same line on top of itself. Okay, and in that case, there's an infinite number of solutions, right? This would have infinite solutions. And in this case, we call it consistent because there's at least one solution, but we call it dependent because the lines are the same. They're not able to stand alone. They're the same line. So this is a consistent dependent system. So infinite solutions means it's consistent, dependent. Okay, so let's try that again. Okay, let's see here. One solution, no solution, and infinite solutions. Okay, and then we have the word consistent. We have the word inconsistent. We have the word dependent. And we have the word independent. Okay, and let me see here. Hold on one second. Okay, so I've cloned these words just to review really quick. When there's one solution, if there is a solution, we call it consistent. right? And so no solution, there are no solutions. It's not consistent. It must be inconsistent, meaning not. Okay. Infinite solutions, is there at least one? Yeah. So it's a consistent system. Now, if it's consistent, it's either dependent or independent. Well, remember, independent means one or to stand alone. And so one solution is a consistent, independent system. Dependent means they need each other, you know, and so that's when we have two lines overlapping. So an infinite number of solutions implies that it's a consistent, dependent solution. System, excuse me. Okay, so let's go back here, and we're going to talk about one more type of system in a minute, a special type of consistent independent. All right, let's solve this system right here. Okay, sorry, let me get my pen out here. I tell you what, I'm going to go ahead and use substitution on this one. I see that 2/5 x and the 5 is going to work out well, so I'm going to go 2x minus 5 over 1 times 2/5 x plus 5. That'll equal 10. And I'm going to go ahead and solve and distribute here. Go voomp and voomp. When I do that, I'll get 2x minus 2x, and then I'm going to get a negative 25, and that's going to equal 10. These will cancel out, so negative 25 equals 10, which is not true. Negative 25 does not equal 10, so there's no solution. That means that this system here is inconsistent. Right? Okay, now let's try this one here. Actually, I'm going to jump to number 3. I want to do number 2 last. Okay, I think I'll do this one by substitution again. I like the slope-intercept form. And I'm going to get that 4x minus 5 over 1 times 4/5 x plus 1 equals negative 5. I'm going to distribute right here. I will get 4x minus 4x. I'll get a negative 5 equals negative 5. These will cancel, leaving me with negative 5 equals negative 5. When does negative 5 equal negative 5? Well, this is always true, right? Always true. So that means that this has infinite solutions. And infinite solutions means that it's a consistent system, but it's dependent. The two lines are actually the same. They depend on each other. Dependent. There we go. Okay. Now this one here, I think if I remember right, it's going to be consistent independent, but I want to graph it. That's why I held off. I'm going to solve it by graphing. So wait, where's my pen? There we go. Let me take it down here, give myself a little more room. Okay, so I'm going to get some graph paper out here. Okay, so there's that line again. All right, let me lock him in place. And I'll graph the black equation. Looks like the y-intercept is 6. 1, 2, 3, 4, 5, 6. The x-intercept is negative 3 over 2. So I'm going to go down 3. 1, 2, 3, right 2. I'm going to go down 1, 2, 3, and right 2. And it's a solid line. And it's going to do something like this. Okay. Now, the y-intercept, on the green equation now, sorry. The y-intercept of the green equation looks like it's going to be negative 4. 1, 2, 3, 4. Right? And the x-intercept is going to be 6. So that's 4, 5, 6, so like that. And so that line is going to do this. And now I know graphing isn't the best way to solve, but there's a specific reason why I wanted to graph this one. Okay, I know you can't tell the exact place that they cross. You can guesstimate it. Of course, we could, use our algebra. We could go 2x minus 3 over 1 times negative 3 over 2, plus 6. And that should equal 12. And of course, I'm going to distribute. And so I'm going to get 2x minus, well, it's going to be 9 over 4. It's actually going to be plus. 9 over 4 is 4.5 x minus 18, and that's going to equal 12. And so I'm going to get 6.5, which I think is 13 over 2 x. And it's getting to be ugly, but we knew that from the graph equals 30. I added 18 to both sides. And so then I'm going to get x is going to be 30 over 1 times 2 over 13. And so that's going to be 60 over 13, which isn't very friendly. It's not going to go 5 because 12, so it's going to be 4. 52, 4 and 8 13ths. Yikes! And then I got to figure out the y-coordinate, but it sure looks like it's going to be -1. I'm not positive about that, but I can plug in -1 for y. 3 over 2x plus 6, which implies that -1, -7 equals -3 over 2x. 14 thirds, yeah. Anyway, I'm not going to worry about doing all that. It's getting ugly. But I wanted to point something out to you. These two lines intersect. It's a consistent independent system, but don't they look perpendicular? And I knew that they were perpendicular to each other before I even started. How could I know? Well, what's true about the slope of parallel lines? Parallel lines have the same slope, right? What's the slope of the black equation? Well, it's -3 over 2. What's the slope of the green equation? Well, it's going to be 2 over 3. See, perpendicular lines have slopes that are negative reciprocals of each other. Perpendicular lines, you can't see what I'm typing, have slopes that are negative reciprocals of each other. Well, what does that mean? That means that if a slope is 4/7, then the slope of a line perpendicular to it is -7/4. I use the reciprocal and change the sign. If I have a slope that equals -5, the perpendicular slope would be +1/5. Because -5 is like -5 over 1, right? So I flip the fraction, use the reciprocal, and change the sign. Take the negative of it. All right, so what have we learned in this video today? We've talked about consistent systems, and consistent systems, they have some type of solution, right? If they have one solution, then they are said to be independent. If they have infinite solutions, then they are said to be dependent, right? This is another way to organize our thoughts. And then we have the inconsistent systems. And those are the ones that have no solutions. Okay? The lines are parallel. Which means that the slopes are equal to each other. Now, with consistent independence, sometimes we get perpendicular lines. And how do we know that? The slopes are negative reciprocals. For example, if m equals 2/5, then m perpendicular is negative 5/2. Okay, that's it for the video. We'll get some practice with this, and we'll be having a test coming up next week. So anyway, Mr. Lawrence signing off. Have a good night, everybody.